Example 3. Determine whether each function represents exponential growth or exponential decay, and then identify the percent rate of change. Okay, so first of all, example A, keep in mind that if we're talking about exponential growth, we have y equals a times 1 plus r to the power of t, and this is growth. And if we're talking about decay, we have y equals a times 1 minus r to the t, and this is decay. Now, specifically, I want to look right in here because this is my growth rate or my decay rate. So if I'm looking in here, anything bigger than 1 is going to be growth, and anything less than 1 is going to be decay. Well, 1.09 is greater than 1, which means it's going to put me in the growth category. So this is growing, which means it's going up. So the question is, well, what's the percent rate of change? Well, a lot of us are going to look at that and go, oh, that's like 109%, or that's 1.09%. Yeah, that's not true at all. Because really, if I want the growth rate, I just want R. I don't want 1 plus R, and this is represented by 1 plus R. So really, we could just think about it, or you could write an equation and say 1 plus R equals 1.09. And if I just want R, you would subtract 1, which means R would be 0.09. That's great, but then it says percent. So we have to change it back into a percent. We move the decimal over twice. The other way of doing that is to multiply by 100. So if we multiply by 100, we're going to get 9% growth. Okay, so that one has whatever the population is. It's growing by 9% each year or 9% each time period. Letter B. Once again, I'm focused right in here. I notice that it's 0.89. 0.89, decay. It's less than 1. Now, decay is a little bit harder to identify than growth because growth, you just add 1. Decay, we've subtracted from 1. So this one I usually always use my formula for, and I say, well, 1 minus R is 0.89. So here I'm going to subtract 1, which, be careful, is going to leave you with a negative R. Then if we take 0.89 minus 1, we're going to get negative 0.11. Then here I have 2 negatives, so we're going to divide both sides by negative 1, which gives us R equals 0.11. And there is your decay rate. Keep in mind they wanted a percent, so we're going to multiply by 100 or move the decimal twice, which gets us 11% decay. Okay, so if this were a story problem, this would be going down by 11% each year.